So this section is on section 1.3 is on new functions from old functions. Again, we have these basic functions we're dealing with, and now we're going to transform them into new functions from the old ones. So some of the transformations we can do is shifting. So shifts are things like you take a function and you add some number to it. This would go up or down. This shifts up or down. It up if the k is positive, or down if the k is negative. You can also have, so all it does is take your function and shift it totally up in the graph. Another function you could do is you could take a function and you could add a constant to the variable first, and then it would work with basically it shifts the independent variable first, and this actually shifts the function left or right, and it's left if your k is positive, and it's right if your k is negative. And so you can think of it as you're looking to see where the 0 becomes. So if you have x plus 5, that means you've moved over to -5 would make it 0. So you've moved to the left that distance. So these are some of the functions we have that we work with, is those shifts. We can also have some other transformations that are not shifts. You can have reflections. So reflections would be things like negative f of x. And what this does is it reflects about the x-axis. So it just flips it upside down. You can also have f of negative x, which is going to reflect about the y-axis. You can also have where you take functions and you add the functions together. You subtract the functions, you multiply the functions, and you divide the functions. So these are other things you can do to your functions to get some idea of what's happening, and you can kind of add them together. Another thing we also have is composition of functions. Composition of functions is f of g, and it's got this weird little 0 there. You've seen this before. And what it means is you're going to take g of x and plug it inside of f of x. So since the g came second, it goes inside of the f. So an example of this might be if you had f of x equal to 7x squared plus 2, and you have g of x equal to 5x, then you could do f of g of x, which means that you're going to take your f function and you're going to plug the g of function inside of it. So what that means is you're basically taking that g function, which is 5x, and you're taking your f function with 7 times something squared plus 2. And the something in this case is that 5x that was inside of there. So this 5x is now going inside the function and replaces the x. Remember, x is not important. The important thing is basically the set space. So I actually like to think of functions in terms of parentheses. This is 5 of something, f of something is 7 times something squared plus 2. G of something is 5 times something. So think of it that way. Then you see I'm going to square everything. So the 5 gets squared, which of course is 25, and the x gets squared. So that's 25x squared. And then you just multiply 7 times 5, 7 times 25. 7 times 5 is 35, 7 times 2 is 14, and 3 is 175x squared plus 2. And so that's how composition works. And you can do other compositions too.